Alright guys, welcome to this set of video lessons. These are going to go with the notes corresponding to Chapter 1, Section 6 out of your textbook. What we're going to be doing in this set of notes is we're going to be looking at solving compound inequalities. Alright, solving compound inequalities. And I have a couple of objectives here, learning targets for you that goes with this set of notes, things that you should be able to do by the time we get to the end of this set of videos. Let me go ahead and highlight those for you. By the time we get to the end of this set of videos, you should be able to solve compound inequalities. You need to be able to solve compound inequalities, and we'll show you how to do that right away here. And then you need to be able to solve absolute value inequalities. So solving absolute value inequalities, and those will come a little bit later on in the notes. So here we go, let's just jump right into it. Let me slide this up for you, and here's what we've got. There are going to be two types of compound inequalities. We're going to want to look, well, we will look at both of these. The two types are these. You can have an inequalities joined by the words and or. Alright, so your compound inequality will either have the word and in it, or it'll have the word or. And these are going to mean two very different things. So we're going to go ahead and jump right into this, starting with the and compound inequalities. Now, one of my favorite places to eat is Five Guys. Absolutely love Five Guys burgers, but I also really enjoy their real French fries. So every time I go to Five Guys, I always order a burger and fries. Burger and fries. Now, if they call my number and I go up to get my order and my bag only has a burger in it, did I get what I asked for? No, because I ordered a burger and fries. Both of them must be present in my bag in order for my order to be complete. The same is true if I walk up there, I grab my bag and it only has fries in it. I did not get my order because I asked for a burger and fries. Guys, that's exactly how these compound inequalities with and is going to work. You must satisfy two conditions at the exact same time. Let's go ahead and take a look at one. Right here I have for you that I want all values of x to be greater than or equal to a -4. Well, what they've done, let me highlight it in blue for you as well. They have found -4 on a number line. We're used to that from the previous notes, graphing things, inequalities on a number line. -4, it's a filled in circle because it's greater than or equal to, and they've shaded everything greater than -4, right? Everybody going in that direction. But here's the point. If you pick a number that is less than -4, it does not satisfy this first inequality. If you chose -5, -6, -7, -8, none of those satisfy the inequality greater than or equal to -4. So let me draw a green line right here. We are not allowed to be less than -4. We'll draw our green line right down here. All right, there it is. I cannot be less than that number. Can't be less than -4. But you have another one. It also says you must be strictly less than a +3. Well, so they went ahead right here. They found 3 on a number line. It is an open circle because it's strictly less than. And they have graphed everything less than negative or a +3. Let me do that one in red. Oh, sorry, I want my highlighter, there it is. There we go. I need everything less than a +3. What that means is that if I pick a value greater than 3, I don't satisfy this inequality. A number greater than 3 would satisfy this one, right? It's bigger than -4, but it wouldn't satisfy this one. It would have to be numbers less than 3. So let me draw a red line down through this guy just to say, hey, I cannot be, oh, sorry, that is my highlighter still. There we go. Draw a red line right down through here just to say, hey, I need all of my numbers to be less than this guy. And so now what we've come to is your final answer, your final graph, which shows all of the values that satisfy both conditions. Every number that is both greater than or equal to a -4 and at the same time is less than a +3, and those are the numbers that they have highlighted right here for you on the number line. You're satisfying both conditions at the same time. If you were to pick a number greater than 3, like let's say we went with a +5, is +5 greater than or equal to a -4? Yes, this one's okay. But is +5 less than 3? No, it's not. I've only satisfied one, not both. Same thing down here. I could choose a -5. Is -5 less than a +3? Yes, it is. But is -5 greater than or equal to a -4? No, it's not. So anything outside of this shaded region is not going to satisfy both inequalities at the same time, and therefore would not be a solution to this and inequality. And means both must be satisfied at the same time. Now what I've got for you right here is essentially exactly what I just explained to you, except with a little bit of set notation, which you guys don't need to worry about. When you get to college algebra, we'll go over this a lot more with you then. I just want you to see it because your book does mention it, but I will never use any of this notation on a quiz or a test. They don't even use it in your homework. But here's what it says. The values of x are all of the elements from set A and set B. This intersection means you're choosing the elements from both sets that are the same, right? So all of the elements from set A and all of the elements from set B that are the same number. Let me scroll back up. You can see here, right? -3, -2, -1, 0, 1, 2, 3. Those are all elements in this set. Those are all elements, right? 2, 1, 0, -1, -2, -3, -4. Those are all elements in this set as well. By taking the intersection, I'm choosing the values that are in both sets. And these are the only values that show up in both sets. Writing that mathematically is like this, with just some set notation. Again, I'll never ask you to do it though, just so that you know what it looks like. And I apologize, there's actually a typo here that I just spotted. An intersection needs to be N. So we're looking for, I'm sorry, not an actual N, just an upside down U. Fix it. There it is. So it is the intersection of set A and B, the intersection of set A and B. All right, that takes care of everything on this page of the notes. Head on over to the next page. We'll actually solve a couple of and compound inequality problems, and I'll meet you there.